right, we are scooting along with our rational units. We have learned what a rational number is. Remember, rational is any fraction. It's actually, it can be any number that can be written as a fraction or quotient, a over b, such that a and b are integers, okay? Now we're going to scoot to converting rationals. Convert just means change. Your learning target, you can translate rationals from decimals and fractions. All right, terminating decimal. What do you think? A decimal that? What do you think?
Gets rid of itself.
Gets rid of itself. That maybe if you're terminated, you end. A decimal that ends. A terminating decimal is a decimal that ends. Like 1/2, 3/4, 3/5. Those are decimals that end. A repeating decimal is has a pattern. Repeating decimal has a pattern. I feel like 1/3 has a pattern, doesn't it? 1/3 is 0.3 repeat, isn't it?
Yeah.
Another pattern would be 2/3. 2/3 is 0.6 repeating. That's what I mean. Another repeating would be 0.25, 25, 25. The 25 is repeating. Okay? They have a pattern. All right. So, recap from 6th grade. Converting between fractions and decimals. You want to go top divided by bottom. That means that the bottom number goes on the outside, the top number on the inside. Now 5 does not go into 3, so I need to add a decimal. I put it on top right away and a placeholder 0. 5 goes into 30 6 times, so it's 0.6 or 6/10. If you got a 3 out of a 5 on an assignment, it would be 60%, right? 0.6, scoot decimal 2 spots to the right, 60%. Converting with mixed numbers, I always deal with the fraction first, so I deal with my 2/3. This is one I want you to get to know by heart. If you don't, you should get there. 3 on the outside, 2 on the inside. Notice I don't even think about the 4. The 4 is just kind of hanging out to the side until the end. 3 goes into 26 times. 6 times 3 is 20 or 18. 2 remains. I see I have another 20, so I know it's going to repeat. So it's 0.6 repeat, and then you just throw the 4 out there. 4.6 repeat.
Can't you just like cross it the 4 and put it like put 12, add 12 to this top, and then 3 divided by 14?
Oh, yeah. So Cooper had a technique. Couldn't he just go turn this into an improper fraction? You could definitely do that. It's not my personal style, but it's totally okay. Meaning, can we turn 4 and 2/3 into 14/3, and then go 3 and 14? 3 goes into 14 4 times. 6. And then notice that it's repeating. 4.6. That is definitely an A-OK strategy. Converting from decimal to a fraction. From decimal to a fraction. You go number over the place value, right? Number over place value. So place values, just to remind yourself, make 3. This is tenths, hundredths, and thousandths. There's place values. So 0.20, well my number is 20, so I would turn that into 20, over my place value is 10 hundredths, 20 over 100. I can simplify that. I can cross out those common zeros to help my simplification a little bit more. And I actually get 2 over 10, which is 1/5. 4 and 45 thousandths. So I have the 4 is the whole number, so that's always just sticking to the side. That's a whole number. And then I have my number, which is 45 over my place value, tens, hundreds, thousands. 4 and 45 thousandths. Now I can simplify it. That's 4, divide them both by 5, 9 over 250. 4 and 9, 250ths. Comparing fractions and decimals. I like now that you know it or remember the official way to convert to a decimal, I would say convert to a decimal. Converting to the decimal is usually much easier than finding a common denominator and changing everything into a fraction. So, for instance, 0.456 and 2/3, I just know 2/3 is 0.6 repeat. But if you don't remember that, you could do it the long way. You could say 3 on the outside, 2 on the end, and notice that it's going to keep repeating. So I know that 0.6 is bigger than 0.456. Drake said. 5/7 and 0.634. I don't know 5/7 off the top of my head. I have no idea. So I'm just going to figure it out. 7 goes into 50 7 times. I can stop there. I already see I have a 0.7. Compare it with a 0.6. The 0.7 is bigger. So I don't go through and find all the work. I only go through until I get what I need. Okay? Make sense? All right, we're gonna order again. I want you at this time, I want you to go through, actually this first one's kind of easy. When you order fractions and decimals, this is a typical MCA style question. They're gonna give you some fractions and some decimals and say, put them in order. The first thing you wanna do is maybe get them all into a decimal or fraction. You can do a fraction if you are all into fractions. I am not a lover of fractions, so I try not to use fractions if I don't have to. Put them in order, and then I make sure they are in their original form. Okay, so negative 3/4 is a negative 0.75. 2/3 is 0.6. Remember, the bigger the negative, the smaller the number. So which one is the biggest negative, 0.8 or 0.75? 0.8 is. So 0.8 is going to go first, negative, followed by the only other negative number. And then what? Ooh, what did I do wrong here? I just did something wrong. Carter, what did I do? I didn't, I put it in the form I made. That is not how they gave it to me. I have to put this as negative 3/4. 0.45 and 0.6. How do I write 0.6? 2/3. All right, the next one I'm going to have you go through and turn them all into a decimal. Turn them into a decimal and then put them in order. All right, converting them, and I'm going to just assume that we all don't know what they are. So I'm going to go the long way to convert, okay? 0.4 is already converted. 3/5, oops, I forget. So I know that I put the bottom number on the outside, the top number on the inside. 5 can't go into 3, so I add that decimal and placeholder 0, 0.6. 1/2, oops, I forgot what 1/2 is. Whole number on, or the bottom number on the out, top number on the inside. That would be a 0.5. Oops, I forgot what 3/10 was. Bottom number on the outside, top number on the inside. 10 goes into 33 times. All right, so I got them all in decimal form. And you'll get to the point where you can do this super fast, translating them or converting them. So my smallest decimal is 0.3. How was 0.3 given to me? 3/10. My next smallest number is what? 0.4, which was given to me as 0.4. What's my next smallest number? Which was given to me as? 1/2. And my next smallest number? 3/5, 0.6, which was given to me as 3/5. Awesome. Okay. This next page is pretty intense. Okay? Once kids get them, they love it. They think, like, they're like, ooh, I want to do that again. It's going to seem really abstract at first. All right? It's going to seem pretty abstract. But I'm going to guide you through the first couple of them, then we're going to practice this strategy. So we can, remember, any repeating fraction or any repeating decimal is a rational number. Okay? Because I can convert it into a fraction or a quotient. So to write it, what I do is assign a variable to represent the pattern. That means x equals something. Actually, more specifically, what we say is let x equal, and then inside this box is going to be the pattern. Let x equal the pattern. That's the first thing we're going to do. And then we're going to get rid of the pattern to the left-hand side of the decimal by multiplying by a power of 10. Because multiplying by a power of 10 just moves the decimal over. For instance, 3.5 times 10, I'm just moving this decimal one spot, it turns into 35. Okay? 0.8 times 10, I'm just moving this decimal one spot, and my final answer is 8. So I use that strategy to move my decimal to get the pattern to the left-hand side. And then I get the variable alone. You will see. I want all of you to watch me with this first one. Don't copy it on your notes because we're going to do it over again. So just watch me. All right, so the first thing I see, I want to write 0.3 repeat. Most of you already know that 0.3 repeat is 1/3. I'm going to show you how to get that technically. So I say let x equal 0.3 repeat. X is the pattern. The pattern is 0.3 repeat. Then I only have one number to the pattern, so I'm going to say 10 times x would equal 3.3 repeat. Because all multiplying by 10 is doing is moving that decimal one spot. Then I want to get rid of the pattern. I need to get rid of it. Well, the pattern is x. So take an x away. X is actually the pattern, though. All right, it's just like if I had 3.3333, take away a 0.3333, all these cancel out. I'm left with just 3, and 9x equals 3. Divide through by 9, x is 3/9, which is 1/3. I'm going to do it again. Don't copy it yet. I'm going to re-solve this problem, or recreate it. And then this third time you're going to do it. Let x equal 0.3 repeat. Let it equal the pattern. There's one number to the pattern. So 10 times x would be 3.3 repeat. I'm going to take an x away because that gets rid of the pattern. So I'm going to take an x away on both sides. 10x, take away an x, I have 9x equals 3. Divide through, x is 3/9, which is 1/3. Your turn. Okay, the next one we have two numbers to the pattern, so we're going to want to move the decimal 2 spots. So we'll times by 100, right? We're going to let x equal the pattern, 0.72 repeat. X is that. X is the pattern. Then 100 times x is 72.72 repeat.